So we've been talking about probability and odds. Today we're going to focus on compound probability. And basically this is when you have more than one thing happening. Now, there's two different types and you need to know which one you're in before you start. So the first type we're going to talk about are independent events. And what this means is that the first event has no effect on the second event. So let me give you an example. Let's just say you're gonna roll a number on a number cube. Roll a number on a number cube. And then you're gonna roll again. Your answer for the first roll has nothing to do with your answer for the second roll, right? They have nothing to do with each other. You roll once, you pick it up, you roll again. Maybe you'll get the same number, maybe you'll get something different. They have nothing to do with each other. The first event has no effect on the second event. So roll a number on a number cube, then roll again. So you're doing two things. You're rolling once, and then you're going to roll again. Because these events have nothing to do with each other, one doesn't affect the other, all we have to do to find the probability is take the probability of each event and multiply them together, okay? So, probability of independent events you're going to take the probability of the first event times the probability of the second event. So it's actually pretty easy. I know this seems like a lot of words right now, but let's do an example. I want to know what's the probability of me rolling a 4, then a 5. So let's say I'm playing some weird game, I don't know, and I have to roll a 4 and then I have to roll a 5. I want to know what are the chances that this is actually going to happen. Well, what's the probability of you rolling a 4? 1 out of 6. What's the probability of you rolling a 5? Still 1 out of 6. So if I multiply those two together, what do you get? How do you multiply fractions? Straight across. You multiply straight across. 1 times 1 is 1. 6 times 6 is 36. So you have a 1 out of 36 chance of rolling a 4, then a 5. Does that make sense? So what do you think the probability would be of rolling a 2, then a 3? It's still going to be 1 out of 36, right? It wouldn't be any different. What's the probability of me rolling, I don't know, a 6 and then a 6 again? It's still 1 out of 36. It doesn't matter. So let's try one where it's a little bit different. Say we wanted the probability of rolling an even, then a 5. So what's the probability of me rolling an even number? What'd you say, Cohen? 3 out of 6. And then the probability of rolling a 5? 1 out of 6, right? So if you just multiply straight across, you can also reduce first if you like. It's up to you. 3 out of 36, and then that reduces down to be 1/12. Let's try a different scenario that's independent. Let's say you are going to actually, let me give you a scenario. Let's say you have 4 red marbles 6 green, and I don't know, 1, I don't know, yellow. So you are going to pick one at random, then put it back and pick another. This still represents an independent event because I'm going to pick the first marble, pretend they're all in a bag. So I pick one marble out of the bag, I see what color it is, but now I'm going to put that marble back in. And so when I go to pick the second time, the probability is going to be the same as the first time of everything happening because nothing has changed. I put the marble back, so I'm still picking out of the same number of marbles. They're all still in there. Okay? So let's find the probability of selecting a red, then green. So, what's the probability you're going to select a red marble the first time? 4 out of 11, right? There's 4 red marbles, and there's 4, 10, 11 total. So I have a 4 out of 11 chance of picking a red that first time. So I picked the marble out of the bag, I saw what color it was, I put it back in. So now when I go to pick the second time, what's the probability I'm going to pick a green? What was it? Probability of picking a green. 6 out of 11. So I can't reduce anything, so I just multiply straight across. You have a 24 out of 121 chance of that happening. What about picking, let's try this, a yellow, then another yellow. So there's only one yellow in the whole thing. So I want to know what's the probability that the first time you pull out a marble, it's the yellow one, you put it back, you mix them up, and now you're going to pick the yellow one again. So what's the probability that you pick a yellow the first time? Nobody knows? Probability of picking yellow the first time? One out of 11. If I'm going to put the marble back, what's the probability that I pick the yellow again? 1 out of 11 again. Multiply straight across. That's 1 out of 121. Right. So I want to know, you picked out the yellow one, put it back in, and now I want to see how likely is it that you're going to pick that yellow one again. So if you're going to pick 2 marbles, one, look at it, put it back in, mix them back up, pick again, only 1 out of every 121 times, approximately, that's going to happen. This is compound probability, and this is an example of an independent event, when the first event doesn't have an effect on the second. Okay, now I think we're ready to talk about dependent events, where the first event does affect the second one. So, dependent events. The first event affects the second event. I'm going to give you basically your general formula for this, and then once we do a couple of examples, I think it'll make a lot more sense. So the probability of a dependent event, or really two dependent events, I'm going to take the probability of the first event happening just like normal. That's the same. Probability of my first event, just like I always do. But now, I have to multiply it by the probability of the second event after the first has happened. So, I'm going to go back to my marble example. Just to make the notes complete, I'm going to write them here again. Yeah, after the first. So, you have, let's see, what was it? 4 red, 6 green, 1 yellow marble. This time, you're going to pick them and you're going to keep it. You pick one at random. Keep it, then pick a second. Okay, so let's watch how this changes things. So the first example I did before was red then green. So let's stick with that. So again, I want to choose a red, then green. But here, I'm not putting the marble back in. I'm going to pick a marble out, and I'm going to keep it, and then I'm going to pick a second one. So what's the probability that I pick a red the first time? 4 out of 11. That's still the same. That has not changed. 4 out of 11. Now, when I go to pick the second one, 6 out of 10, he says. Why? Right. There's still 6 green marbles in there, but now there's only 10 marbles because you kept it. So there's only 10 marbles left to choose from. So that's the difference here. This is going to be affected by this one. I kept the marble, so now there's not 11 marbles to choose from anymore. There's only 10. Yep. Yeah, so if I pick a third, it'd be at a 9, 8, 7. Yep. So I'm going to pick these two. You can reduce first if you like. I do like. So I'll make that a 3 and a 5. So I get 12 out of 55. Very different from our answer from before, which was 24 out of 121. They're different. So you have to be careful if it's an independent or a dependent event. So let's try another one. What if I wanted to choose, well, let's do this. How about I want to pick a green, then a yellow. Everybody go ahead and fill this in. Try it. See if you can come up with what these two should be. I'll give you about 20 seconds. Okay, what's the probability I'm going to pick green? 6 out of 11. How about yellow? 1 out of 10. Very nice. Is everybody okay with why those numbers are what they are? Yep.
Yeah, I'm fine with that. But say you like accented like 6 over 10 and 1 over 11. Well, that one will screw your answer up, right?
No, but
It's not right.
right. You'll get the right final answer just because you're going to multiply straight across. So I'm going to reduce first. So that would be a 3 over a 5. 3 out of 55. Okay. I'm going to change gears on you now. I wonder if you can figure this one out. Pick a green for me, and then pick another green. Try that one. I'm giving you a hint that this one's a little bit different. You got to think on this one. Go ahead. What's your first one?
So 6 over 11.
6 over 11, I agree.
And then 5 over 10.
Yes! 5 over 10. Think about it. If you picked a green the first time and you kept it, there's not 6 greens left the second time. You already picked one of them. So now there's only 5 out of 10. Do you see? Are you with me? You picked a green, then when you go to pick another green, there's one less in the bunch. One less green and one less in the total. So now I can multiply straight across, but I prefer to reduce first. 3 over 11 would be my final answer. Did you get that? Oh my gosh. So everybody do red then for me. It's the same idea. Try red then red. Oh, sure.
These are me. These.
Gustavia.
Yeah.
So for the
Going
yellows,
from this to
so
this is
there's
me.
1 over 11.
So,
what do we do for the
you got
second
this,
part?
this,
0 over 11.
so. let's say
Well, it'll be 0 over.
you do,
0.
I would say 3 out
Oh,
of
0
5. And I
over 10.
told them
Right.
that.
But would it be 0 over 110?
Which is just what?
110. 0?
Because think about it, you can't, it's impossible. You can't pick the yellow twice. Because you can, there's only one, so you would only pick it the one time. So it's impossible for you to pick the yellow, keep it, and then pick another yellow, because there isn't a yellow the second time. Yeah. Okay. Kayla, what would be the probability of picking the red the first time?
4 over 11.
Correct. And then the second time?
3 over
Perfect. There's one less red because you already picked one. So there's one less red, which means there's also one less in the whole bunch. I like to reduce first. You don't have to, but I find it much easier. 6 out of 55. And then, I don't know if you guys were just heard what Nate and I were talking about. If I tried to do yellow, then yellow. What's the probability you're going to pick yellow the first time? 1 out of? When you go to pick, remember, you're keeping it. So if you just pick the yellow marble out, when you go in there to reach,
You're not going to pick another one.
there isn't another yellow. So it's 0 out of 10. But when you do this math out, what does this, what's that equal? 0 over 110, which is 0. Think about it, guys. It's impossible. If something has a probability of 0, it means it's never going to happen. It's impossible for you to choose a yellow, keep it, and then choose another yellow if there's only one in the whole set. Does that make sense? Okay, good. Do you want to try, let's just put 3 things in. Let's say I want to find the probability of choosing, say we did 3. Let's say I want to pick a red, then a green, and then a yellow. So we're going to pick 3 things. We are not putting them back. I just do the same thing, but now there's 3 of them. So what's the probability I'm going to pick a red? 4 out of 11, right?
Wait, you're putting them back?
No, I'm not putting them back. I'm keeping them. So I picked a red. What's the probability now I'm going to pick a green? 6 out of 10. And what's the probability I will select a yellow as the last one?
Or 9.
1 out of 9, right? Because I'm keeping them every time. So there's going to be 1 less every time. So now, if I just do that math, we will have our answer for 3 things in a row. Let's see. I like to simplify. 2 over 5, 2 over 3, and I think that's it. So it would be a 4 over 165. Thank you. Cool. All right. Does all this make sense? Okay. Tell me if this is a independent event or a dependent event. So remember, independent means the first one has no effect on the second.
Just dependent.
Dependent means that the first one will affect your second one. Okay, let me give you this scenario. You have a deck of cards. You pick a card, you put it back, and then you pick another. Was that dependent or independent? That's independent. The first one had nothing to do with the second. The probability was just the same as for the second one as it was for the first. Let's say, I don't know, you have 10 shirts in your closet and 3 of them are green. Okay? Assuming you're just going to pick a random shirt out of your closet today and then a random shirt out of your closet tomorrow, what's the probability that you wear green today and green tomorrow? Is that independent or dependent? Dependent. Because you're going to pick a shirt today. You're not going to take your dirty shirt off and put it back in the closet.
Well,
You never know. But assuming that you are wearing one shirt each day, and then, eventually it'll get back in there after you wash it. But between today and tomorrow, assuming you're not doing any laundry, that's going to be a dependent event. How about socks in your drawer, right? If you pick a pair of random socks to wear today, and then a random pair of socks to wear tomorrow, is that an independent or a dependent event? It's dependent, because tomorrow there's going to be 1 fewer pair of socks in there than there was today. Independent or dependent? Say I had 2 spinners, and I spun 1 spinner, and I spun another spinner. Independent. This spinner has nothing to do with that one. Say I had the same spinner, and I spun twice. That's...
Wait, no, that's dependent. Because you only have 1.
Well, say I have a spinner, I spin, I get an answer, and then I spin again. They're independent. So my second spin, it wasn't affected by my first one. I could get the same answer, I could get a different answer. There's no fewer or more choices than I had the first time. So that would be independent. Okay? You want to try some? Let's hope that this recorded.